Good day, everyone. Now we are going to talk about mathematical induction, and I want you guys to listen attentively and jot things down that I'm about to say here. Now, mathematical induction is a powerful method or mathematical proof used to establish that a given statement, which is denoted by P as in N, is true for all natural numbers, is greater than or equals to the some starting value, usually n is equal to 1, which is also known as the base step, and is based on the analogy of row of dominoes. Now, one particular thing about induction is that any value that you get on the left hand side must be equal to the right hand side. That is, you must know that, let us say 5 plus 5. 5 plus 5 is always equals to 10. So the thing is, any value on the right hand side must be equal to the left hand side, and any value that is on the left hand side must be equal to the right hand side. Now, listen attentively. We have some principles of mathematical induction, and we have one I have one particular theory you must take to notice anytime you are dealing with the principle of mathematical induction. First of all, know this particular acronym, which is TAP. T stands for test, A stands for assume, and P stands for proof. So now let us dive into the principles of mathematical induction. Tests, which is also known as the base case, we show that what the statement is true. Usually n is equal to 1. That is, most of the time when you are dealing with base step, we first of all test for when n is equal to 1. Then now we go to assume. Assume is said to be what? Inductive hypothesis. We assume. Now assume the statement is true for n is equal to k for some integer. That is, you assume that n is equal to k after testing for n is equal to 1. Then now we go to the last principle of mathematical induction, which is known as the induction step. We prove using the assumption in step 2, which is the inductive hypothesis. We prove that the statement is also true for n is equal to k plus 1. That is, we show that the statement is the same thing as k and k plus 1. So now let me show you, let us dive into the general formula which most of us must know, which is 1 plus 2 plus 3 plus dot dot, which is so on, plus n, which is known as natural number, is equal to n open bracket n plus 1 close bracket over 2. This represents left hand side, this represents right hand side. That is, any value on the left hand side must be equals to the right hand side. Now, using this formula, let's prove using TAP, which is what I claim it to be. T for represents test, A represents assume, and P represents proof. Now, let us go. For here now, we now have test here. For n is equal to 1, the left hand side is equal to 1, which is already, we are dealing with this particular place, which is the left hand side, which is 1. Then now we are going to put the value of 1 inside the n here, which is going to be 1 into bracket 1 plus 1 over 2. So when you multiply this, 1 times 2 is equal to 2. 2 divided by 2 will give you 1. So we have tested for when n is equal to 1, which is according to the principle of mathematical induction. Then now let us go to the second step, which is to assume. Now they said assume for n is equal to k, which is already in the principle that we assume that the statement is n is equal to k. So represent anything as n to be k. So you can see here that we represented everything, we denoted it as k, and this is what it gave us. Then now lastly we prove, which is known as the induction step. We prove that for n is equal to k plus 1, we have to know whether it is true or not true for n is equal to k plus 1. How do we do that? Using the assumption that we already gotten before. The assumption is said to be what? K into bracket k plus 1 over 2. We replace it with this particular value n, which is k plus 1 plus k plus 1. Then first of all, after doing that, when replacing them, we make the denominators the same. How do we do that? We multiply 2 to this particular value, making sure that the denominator and this particular value are the same. So when we multiply 2 by these values, 2 the numerator and 2 by the denominator, it was now the same. Then we now combined the two of them together. After combining the two of them together, we saw that this particular value are the same. Then we bring them together, we combine them. It now give us this value, k into bracket k plus 1 plus 2 into bracket k plus 1 over 2. Then after combining them, we do what? We factor out the common term. As you can see here, k plus 1 is common here and k plus 1 is common here. According to us in normal quadratic, we believe that anything we see like this, we cancel out. Then we write it as 1 as a whole. We factor it out. Then into we what? K plus 1. Why this one we tag to what? K plus 2. So k plus 1, k plus 2 over what? Over 2. That is, when factoring all these things, you can see that it was represented as what? K plus 1 and what? K plus 1, close brackets, what? Plus 1. That is, the statement is true for what? K plus 1. Now let me, most of you might not understand this particular theory. Let me break it down to its simplest point, and I hope you can understand what I'm saying here. Please listen carefully. Now, in order to understand this particular theory of mathematical induction, it's just a mathematical proof. Now, the thing is, now in every number that we always talk about, 0, 1, 2, 3, you can see that it is increasing by a difference of what? 1, and increasing by a difference of 1. So these numbers, their gap is what? Is increasing through the value of 1. So even the same thing that when I'm mentioning the even numbers like 2, 4, 6, 8, you can see the gap distance between them is 2. So the thing is, it is increasing by what? Plus 2. Likewise, the cases here, let us say this is what? 5 plus 1. We represent k as what? 5. And we present 5 also here as k here. 5 plus 1 will give you 6 normal. And this one will also give you 5 plus 1, which is 6, plus 1, which is 7. So it is continuous at this particular case here. So after 6 will always be 7, and after 7 will always be 8. Likewise, the same thing for this particular theory. Now, looking at this general formula here, let us look at it. We tested that when n is equal to 1. Now, let's test for when n is equal to 2. When n is equal to 2. When we put 2 here, 2, we present it as n here, 2, which is here, and 2, which is here too. 2 plus 3. 2 plus 1, which is what? 3. 3 times 2, 6. 6 divided by 2, which is 3. 2 plus 1, 3. Now, let us prove for when n is equal to, test for when n is equal to 3. 3, we put 3 here, and we put 3 here. 3 plus 1, 4, right? 4 times 3, which is 12. 12 divided by 2, which is 6. 3 plus 2 plus 1, which is what? 6. So you can see that the values of the left-hand side is correlating with the values of the what? Right-hand side. That's why the statement here is true for k plus 1. I hope you guys understand this brief explanation that I gave so far. And it's very simple. Very simple. Just follow the principles here and know the acronym of what? TAP, which is what? Test, assume, and prove. And everything will be simple thereafter. Just know the general principle of this, and always note that the what? Left-hand side must be always be equals to the right-hand side. If the case that the left-hand side is not equals to the what? Right-hand side, that is, the statement here is not true. Do you get me? Thank you so much. I hope this video help you guys in understanding mathematical induction. Please like, follow, and subscribe to my YouTube channel, and also share the link to any of your friends that have difficulty in understanding mathematics. Thank you so much. Bye for now.